Okay, we're just going to have a look at a short video to really explain a little bit more about this particular function here, int, which we've used, and to explain the context of it. So, as I'm sure you're aware, or you may not be, I don't know, when we do things like name is assigned Fred, Fred is obviously a string because it's in quotes, and this string of characters is assigned to the variable name. So what actually goes on? Well, obviously the characters FRED need to be stored in memory somewhere, and essentially, not quite right, but it's not far off the truth. What we do is we convert each of these letters FRED to their ASCII values. Now, if you've not seen ASCII before, what I've got here, get it to come up, is the ASCII table. So if you have a look in the ASCII table there, capital F, which is up here, has got the decimal value 70. So we'll store a 70 in the first byte in memory. R is 82. E is 69. And D is 68. So those actual values there get stored in computer memory, and name, the variable, is actually a label, and that label then points to this memory location where our string is stored. There is actually a special end of line character just to show me where the string ends. And it's dynamically allocated as we created the variable name. Because we've got 4 ASCII characters here, it created enough space in memory to store those characters and a special end and some other bits as well. And name now points to this memory location and is a string variable, so it knows it's pointing to a particular string. If, on the other hand, we do something like age equals 45, well, 45 here is not in quotes, so it's not a string. So what does the computer do? It creates dynamically some memory and puts the number 45 in there, and then the label age points to 45 as a integer type variable. This is an str, a string type variable. So that's all well and good, and some programming languages you have to predefine what type of variable you have before you store the information in there. Python is what's called dynamic, so you just use the variable name and Python will work out what kind of variable to make it. So where does it all go wrong? Well, it starts to go wrong, so we think, when we use a function such as input. So we know from looking at the code, input returns a string, and we put that into wherever we want, whatever variable we want. And we might well put that into a variable called age, because we've just previously here asked the question, how old are you? So imagine the user now has typed in the number 45 at the keyboard and hit return. Input actually returns this as a string. So input returns this as the string 45. So what happens? Well, we've just talked about what happens when a string is allocated. It looks and says it's a string. It allocates enough memory for it. It looks at the character 4, and if we go back to the ASCII table, we'll see over here the ASCII value of the 4 is 52, and the 5 will be 53. And our age variable will point to this memory location. Again, remember it's actually got an end character on there. And obviously it's a str type variable, it's a string type variable. It's an ASCII character for 4 followed by the ASCII character for 5. So when we try and do maths with this and do something like age is assigned 100 minus age, Python, at the point we try and do this subtraction, says, hang on a minute, I don't understand what it means to take away, subtract a string from a numeric variable, and that's where the error occurs. So what we have is we have a function that can look at strings and, if it's possible, convert them back into their numeric value. So it could look at this string, which is a 4 and a 5, and convert it back into the numeric variable, or the value 45. And the way we do that is, so that was a bad example saying age there, you get the idea. We say age equals int age. So what's going on in this statement? In this statement here, we're taking age, which is currently a string. We're passing that as an argument to the int function. The int function looks at that string and goes, oh, okay, this is an ASCII for a 4, that's an ASCII for a 5, it's a valid number. It turns it into the number 45, and it returns 45 as a numeric variable. And it now puts that into the variable called age. Hang on a minute, the variable called age has already got a string in there. So what happens? Python, as we'll learn as we go on, doesn't really care. We reallocate things to variables all the time. It doesn't matter that it used to be a string and now it's going to be an integer. Because all Python does is Python goes and stores the number 45 in memory somewhere. And remember previously, what was age doing? Age had 52 and 53 in there. Age was pointing to a, or labeling a string variable. When we do this command down here, age is assigned int age, the number 45 comes back and is assigned to age, 45 is put in memory, and age now just points to a new location. And age is now referencing a numeric variable. So now we can get on and do things like years to 100 equals, or is assigned 100 minus age. And that will work because age is now a numeric value. So this will calculate 55 and create a new variable called years to age and put the value 55 in there as an integer. So hopefully that clarifies the process. The other points that came out were, a suggestion was that we could do this command, age equals, is assigned int input. Okay, now whilst this would work, and just explain to you how it would work, input obviously gets input from the keyboard, it's returned as a string, so if somebody types in the number 45, it comes back from here as a string 45. So this now is replaced with the string 45, and the string 45 is now the argument to the int function. So we're passing a string 45 to int, and that then will return the actual value 45 into age. The problem with this is we're not involved in the process of checking this return value. If somebody has mistyped something in, and we can imagine somebody typing in accidentally, say maybe typing in 45 with a space because they've caught the space key, or really not understanding the question and typing in the text 45, actually the letters, for whatever reason, if they type something like this in and there's a non-numeric character in here, when we call the int function on this to convert it to an integer, it will throw an error because it can't do it. The problem with this is we can't get in here to check the input return before it's passed to the int function. So if somebody types something in error, when we use a syntax like this, it will always crash. So what we tend to do is we'll say age equals input, or is assigned input. We'll do some form of test in here on age before we'll actually do the conversion. Because now here, if they've mistyped something in, it will come back into a string. We can test the string here, make sure that we can convert it to digits, and basically if no, we can't convert it, we need to go back up somehow, looping back to the top, and get them to re-input it. probably putting a message in there telling them what they've done wrong. If it was right and we can convert it to an integer, we now go on and confidently convert it to an integer. We'll look more about how we do this because it's a very common requirement in programming to validate input before we do things with it. And it's not just to make sure we can convert it for an int. We might have asked the question, please answer yes or no. Well, what do we do if they just hit enter? What do we do if they just put the character L in? Do we ask them again, or do we take a default value? We might give them a range of options. Please enter 1, 2 and 3. 1, 2 or 3. And they go and press 4. Validating input is quite a big part of programming, so we'll look at how that works. Okay, hopefully that was useful and cleared it up for you. Thanks.